Mr. Walker here. Welcome to another math lesson with Mr. Walker. I'm glad to be with you today because we are getting into shape, if you will. Getting into shape. I mean, I know I'm already in excellent shape, but I wish. We are getting into shape today. We are shaping up what we're doing today in class in this lesson because we've been talking about angles, right? Being able to measure angles. We've been talking about how to draw shapes with certain angles. We've been looking at the attributes of shapes with angles and how we can classify them and things like that. And today we're going to get a little bit deeper into that and use shapes to help us determine what different angles are, and kind of use shapes to help us measure things, help us measure the angles in different degrees of maybe some missing angles and things like that. So this one's going to be pretty cool. So here's the thing: if you have, you're going to need a couple things today. First of all, you're going to need something to write on and something to write with, like we always do. If you have a protractor or a circular protractor or any kind of protractor, you might want to have that out today and use it. It might come in handy. And if you happen to have shapes, like some attribute blocks here, right, like any kind of pattern blocks, things like that, you might want to grab those out as well. We're going to need shapes like this, like a triangle. We have a couple rhombuses, rhombi here. We have square and a pentagon there. If you have those available, you can grab those out. If not, there are some printable versions of these as well that you can grab. I'll have them downloadable in the module and things like that. So you can grab those as well and have them out. It's not 100% necessary, but it's going to make things a lot easier and a little more interactive, a little more fun. There's some virtual ones too. I'll try to link you guys to those as well if I can. So once you have that stuff gathered up and ready to go, let's get rolling because it's time to get into shape. Alright guys, so I'm going to start with a square first, okay? So I have a square here, alright? And I actually have like copies of this square. And I'm going to take these squares and I'm going to arrange them around like a middle point here. So let me just move some things around. Here we go, perfect. Okay, so I have my squares here, and if you look, I kind of arranged them all around a center point there, right? So they're going all around this shape here. Now, how many right angles meet at this center point here? So at the very middle where all these squares have met up, how many right angles are there? Right, there's going to be 4, right? Each one of these squares is a right angle. So we have 1, 2, oh, this square keeps wanting to move around. Hold in there, square, hold in there. 3, 4. Those are 4 right angles that meet there in the middle, right? And if I wanted to look at one of those right angles, right, I can kind of trace in here. Let's just kind of grab this guy here, and I'm going to label it, let's label it X, Y, and Z, X, Y, Z. So the angle of X, Y, Z, if I was going to label that here, X, Y, Z, that's going to equal 90 degrees, right? So looking at that, if I was standing right here in this dot, right, and like looking at Z, for example, how many 90-degree turns would there be? How many quarter turns would there be to get all the way around this square? Right, there would be 4 of them. There would be 4 of them. 1, 2, 3, 4. And to get all the way around would be 360 degrees. These are some ideas that we've kind of reviewed previously in some other lessons. Okay, so to get all the way around would be 360 degrees. So if we didn't know that these were right angles, we knew all the way around this shape is 360 degrees, we could use some math to help us figure out what those angles would be. What I could do is I could take that 360 and I could divide it by 4, because we had 4 angles that met here in the middle. I could divide that by 4 and I would get 90 degrees. So that 360 divided by 4, that would give me 90 degrees. So that's a way I could kind of like discover the angle or figure out the angle, calculate the angle of a shape based upon that 360 degrees, based on the idea that to get all the way around that central point would be 360 degrees. Okay? Not too bad so far. So I'm going to go ahead and clear some of this stuff out, and we're going to try this again with another shape. Okay, so now I'm going to take some triangles. And I'm going to arrange the triangles the same way. I'm going to arrange them around a center point, right? So they kind of go around each other. So I'm going to have to take some and kind of move them around a little bit here. And like this. So basically I'm going to go all the way around here. So if you guys have these shapes at home and you want to try it as well, or in your class or wherever you're at, if you want to try that as well, I'm going to keep going here, and then we'll compare what we have at the end, okay? So just give me 1 second. Okay guys, so I have my triangles arranged here. It's not perfect, but it's the best as I can get it up here. But you can see they go all the way around now. So I had to rearrange them so all the points are kind of meeting in the middle. I have these angles meeting right here in the middle of this triangle. So in here is like my meeting point where all my angles are kind of hanging out and pointing at each other. Now, I don't know what these angles measure. So if I was to draw like an angle on one of these and label it as XYZ again, because that's easy enough. So I don't know what that angle measures, right? The angle of X, Y, Z, but I can use what we know about these shapes and what we know about angles to help me figure out what that angle would measure. So I know if I started at like one point here and went all the way around this triangle, or this shape here, all the way around each one of these, that would give me 360 degrees, right? 360 degrees would be all the way around. And that would be, let's see how many turns that would be. That would be 1, 2, 3, 4, 5, 6. 6 turns all the way around, or 6 of those angles, whatever that angle is. There's 6 of them going around there. So if I took that 360 degrees and I divided it by 6, that should tell me what one of these angles is, what the measurement of one of those angles is, and then I could be able to determine that and determine what all of those are working around. And so if I did 360 divided by 6, that would give me 60, meaning if I had 60 degrees in this triangle, and 60 degrees, and 60 degrees, and 60 degrees all the way around, that should give me 360 degrees. So my measurement of one of these angles, XYZ, is going to equal 360 degrees. So I can use these attributes of these shapes, knowing that all of these shapes, all of these triangles are the same, and then knowing that to get all the way around is going to be 360 degrees. I have 6 of these shapes in here, so that means each individual angle is going to measure 60 degrees. 60 plus 60 plus 60 plus 60 plus 60 plus 60, 60 plus 60, 60, 60, 60, 60. Okay, it's going to equal 360. It's a lot of 60s in there, a lot of counting, but you get the idea. Okay? So each one of these angles is going to measure, each one of these interior angles here is going to measure 60 degrees. Okay? So some fun with shapes, right? Fun with shapes. Now before we jump in and take a look at another shape and measure some angles on another shape, I wanted to kind of like ask a question or kind of put something out there. I know we used the math to figure out that 6 of these triangles stacked around each other. It took 6 of them to go in a complete 360 degrees when we met up all those angles. So we divided 360 degrees by 6 to get 60 as our answer. So we're saying that each one of these angles here should measure 60, but how could we verify that? How could we actually check that to make sure that it's true? There's a couple different ways that we could do that. One is if I brought out a triangle here and I brought out my protractor, I could put my protractor over the top and I could measure that angle. Now, I can have an easier job of doing it here because all of my stuff is flat, but if you had those 3-dimensional shapes at home or in your class or wherever you're working, it might be a little bit trickier to do that because you got like a shape that's not completely flat and you're trying to use a protractor on it and things like that. So if you can still line it up to do that, you can do that. So let me scoot my protractor over here. And even here it's not completely perfect, but you can see that it's about at 60 degrees right there. 60 degrees for that. If you aren't able to do that, let's say for example that your triangle is much smaller, right? And I lined it up again, well you might not be able to see like the end of that triangle and how it's lining up. So you could always use your protractor to draw a 60-degree angle. Draw this as best I can. It can be 100% accurate. But you could draw a 60-degree angle on paper and then just kind of fit your triangle in there and make sure that it fits and that it's lining up the same way like this one does here. So other ways that you can verify what the angles would be, besides just using math and equations to figure it out. There are some other ways that we could do it. But the math and equations, it's kind of fun, and it gives us just another twist on things, okay? All right, cool. So let me get rid of these couple things, and let's try another shape here. All right, I'm going to move on to this big guy here. We have our hexagon here, and I'm going to, again, create that 360-degree kind of circle with these shapes, right? I'm going to see how many of these shapes it takes for me to go around. So there's one, and then here's two, and again, I'm kind of meeting those angles there in the middle, whatever angle it is that I'm focusing on. So there's two, and oh, look at that. I think it's only going to take three. Okay? 1, 2, 3, and again, if we look, if I start like here at this line, I go all the way around, it's going to be 360 degrees. So again, on this one, I'm taking that 360 degrees, and I'm going to divide it by 3 to figure out what that angle is, what one of these angles is right here on this shape. Okay, so following these two lines, this could be an angle of A, B, C, and I'm trying to determine what the measurement of this angle right in here is, what that measurement of that angle is, okay? So why don't you give that a try? What is 360 degrees divided by 3? What's that going to give us? What's our measurement of our angle going to be for this shape? Okay, so now looking at this, I have 360 divided by 3 equals 120, which means each one of these angles here is going to be 120 degrees, okay? And if I add it up, 120 plus 120 plus 120, that's going to give me 360. So each one of these angles is going to be 120 degrees. Okay? Easy enough. Okay, we got a couple more shapes that we could try out. And there's a chart or something like this that should be available to you so you can keep track of all of these shapes and all of the angles and things like that that you're getting as you go through. So that's super cool. Make sure that you're keeping track of these. So let me go ahead and clear some of this stuff off. And I'll let you guys have some fun with these last couple shapes if you have them available to you. But let me just show you a couple different things. So this shape, for example, and this one as well, they have two different angles. We have an acute angle on this side. This is an acute angle. And then we have an obtuse angle over here. So there's actually two different angle measurements that we need to find here. So if I first take these and I line up all my acute angles together, there's that, another one over here. Okay, so I lined up all of these with my acute angles in here, and I was able to get 6 going around. So that means that if I start at like one line here and go all the way around, it's going to give me 360 degrees. Okay? So 360 degrees, I'm going to have to take that and divide it by 6 if I want to figure out what each individual angle is going to be. And then I'll be able to do that. Now, I'll let you guys work on that at home because it's way more fun for you to try it yourself, right? But this shape I can also stack up by their obtuse angle, okay? So I could take this shape now, drag a couple up here, and this time I'm going to meet those obtuse angles in the middle. Okay, and I know I'm working on this board here. It's not always exact, but you guys can kind of get the idea as I go through. So there's 1, 2, and then again, if I'm meeting those obtuse angles, there's going to be a third guy in there. Okay, so there's 3 of those in this one. So depending on if I go by this acute angle here, or if I go by the obtuse angle here, I'm going to get 2 different angles, obviously. So this will be 360 degrees divided by 3 to be able to figure out the measurement of each individual angle there. Okay? So you guys are starting to get the idea of how you can use shapes and the attributes of shapes to figure out what individual angles might be in those shapes. Okay? Which is cool and all, but why is this helpful? Like, what's the deal with this? Why do we need to know how to do this? Well, that brings us to the next step of the lesson. So let's take a look at how we can actually use what we know about these shapes to help us out. Okay, so let's take a minute now and let's talk about why knowing the angles of certain shapes might be helpful to us. So up here I have an example, and you guys can probably find this in your downloadable stuff as well. But I have an example here of an angle, ABC, right? Here's the angle of ABC. B, C, all right? And we don't know what that is. And let's say I didn't have a protractor, and I wanted to find out what the angle of this angle, what the measurement of this angle should be, the degrees. You know what I'm saying, right? Say I want to find out the measurement in degrees of this angle. That sounds better. All right, if I wanted to find out this, I could use my shapes. I could stack them in there and help me out, in finding that angle. So for example, like they did here, my shapes are going to be a little bit differently sized, but hopefully this will work. They put a 90-degree block in there, so they knew that from here to here is at least 90 degrees. And then they took another shape and fit it in there as well, and went, oh, look at that. So that 90 degrees, and we know that this triangle is 60 degrees. So 90 plus 60 is going to be 150. So we know that 90 degrees of this square and 60 degrees of this triangle, 90 plus 60 is going to be 150. So we could say that the angle of ABC is equal to 150 degrees. Okay? 150 degrees. So we can use those shapes to help us find the measurement to some angles. All right? Let's take a look at another one. Okay, so for this one, you can see we have an obtuse angle here, and they want us to determine what the distance is there. And if I didn't have a protractor, a certain circular protractor, or anything like that, and I still wanted to determine what HIJ, what the measurement of that angle is, I could use our shapes to help us. So I could take my hexagon here, put it in here like this, and I know that each one of these angles is 120 degrees, 120 degrees. So I know I'm going to have one 120 degree angle here, plus, if they put in a square, plus a 90 degree angle from my square, and that's going to give me, let's see, 120 plus 90 is 210, which means the angle of HIJ will be 210 degrees. Okay? Easy enough. Using the shapes to help us determine the measurement of an angle in degrees. Sometimes, though, they might not tell us what shapes to use. So, for example, here I have an acute angle, angle L here, and I don't know what shapes I'm going to need to use, so I'm just going to have to play around a little bit and see which ones I can fit in there. So, I don't know, it's definitely not going to be 90, right? So it's not going to be 90. Get rid of this guy. Let me see if this one fits in here. And you know what? That one fits pretty good. So we can see that it's 60 degrees. I might keep that one over there for now. Let me just try with these guys just to see. Again, well, and these ones each measure 30. Alright, so I can fit them in here. Let's see. Ooh, that's pretty good as well. So if these are each 30, 30, 30 is 60. So that measures up. That's gonna probably be an equal amount there. So let's try this guy. This is R. Let me move up and get my shapes. Again, I don't know what angle R measures, but I can use my shapes to help me out a little bit here. So let's see. It looks like it's bigger than 90 degrees. So I'm at least going to be able to use a square, I think. So let me go ahead and just put a square in here. That'll give me at least 90 degrees. And I just got this little like sliver left. Let's see if I move this triangle. That's going to be too big, so not that guy. Let me try maybe this guy again. It's almost like a puzzle. Who would have thought you would have been doing puzzles in math, right? Come on now, it's crazy. But I'm going to say that this guy fits in there pretty well. Oops. So I'm going to go with 90 plus 30, which would give me 120. So angle R is 90 plus 30, which would equal 100 and, what did I say, 120 degrees. I should know that. Okay, easy enough. All right, so I think you guys are starting to get the idea with this. So the main goal of this lesson, again, just to kind of review a little bit, was to be able to figure out, based on 360 degrees and stacking those shapes in kind of like a circular pattern around there, based on what we know about 360 degrees, to be able to use that to determine what the angle of each shape would be, of those certain shapes that met in the middle, okay? So we did that, we were able to figure that out, and then we were able to use shapes to stack them up to determine the angles that we didn't know the measurements of, okay? So hopefully this helps, hopefully this makes sense. Again, reach out if you guys need anything, if you have any questions, comments, or concerns. And thanks for getting in shape with me today, guys. I appreciate it. Talk to you soon.